So today I'm going to explain the project that I just finished or just completed, and it's the intersection of calculus and art, and it's calculus in the modern world, and calculus in daily life, and it's really interesting because we're using ceramics, which is a pretty cool art, and it involves rotation and specifically throwing on the wheel, which is this wheel that spins around. There's a lump of clay, and you mold it, and the centripetal force forms it. So the different ways that you mold it, and so it's essentially a rotation. It's essentially a rotation around a certain axis. And today we're going to talk about that same thing. We're going to use calculus to find the volume of that solid, and the way that we're going to do that is through rotation. And so the first part of the assignment is finding a graph or a function, or finding a function or various functions that create a section on the graph which you can rotate around the graph and create a 3D solid. So I started this project with the idea that I didn't want to do the sine graph, the generic sine graph. I wanted to do multiple functions in order to get an interesting shape that I could use and fool around with. And so here I'm gonna graph what I came up with and what will be my eventual plot. Okay, so I'm just gonna give the functions that I used and that I fooled around with and ended up choosing for my project. And so the first function is y equals 2x. Oops. Takes a little bit of getting used to. Y equals 2x, we'll just leave that, plus 1.5. Second function is y equals 0.5. Y equals negative 0.6x squared plus 5. And the third function is x equals 0. So the next step is to graph them. And this is a simple step. Start with 2x plus 1.5. So this is about 1.5. Looks something like this. We don't need to be exact at this point. Y equals 0.5. About a third of that. That'll be across here. The y-axis. And negative 0.6x squared plus 5, the 0.6 widens it, and the negative obviously flips it. Up 5, probably right about here. And x equals 0 is just a line up the y-axis that implies that the function is moving that way. Okay, so now you might be able to start to see that I have my my area that I was going for, and I'll outline it for you. Here it is, right here. So I was interested by this because it would be interesting to flip it, and if you imagine it rotating around the x-axis, you can see that this space right here, one second, I'm going to change it back to black, this space right here is going to be hollow. There's nothing there. So once this flips, this is just going to turn into a cylinder, and it's going to have an equal radius on the other side as well. So this space of 1.5 up here is going to become 3, and that's going to be a 3-inch gap, a cylinder, a hollow cylinder down the middle of my piece. And if you try to imagine this flipped, you might notice that it's going to look something like this. Something like a pie shape. Now, this was all well and good, but the next part of my project was actually the hardest, and this was the calculations. And the calculations required that I find, through integration, the volume of the rotated piece. And so this is an important step because it'll give me the volume of the piece of pottery, the piece of the pot that I'm looking to make, and my partner, who is in the ceramics class, is going to help me make. Okay, so let's get started with the math portion. So right now we have our graph up in the corner. I set that there as a friendly little reminder. And so what we're going to do is create our initial integration function. And so what we need to do, though, just conceptually so you can understand this, is we need to find this area within this space. But in order to do that, because having some trouble with this again. Okay, it's not a big deal. So because this function has two different, because it has so many different functions, since the graph has so many different functions, and these two lines right here are both on the top side of the function, and since when you integrate, you take of a section, you take the top minus the bottom. It's important that you understand that we need to switch functions halfway through. So at this line that drops down, we need to switch between this function, 2x plus 1.5, and this function, negative 0.6 squared plus 5. And that's what makes our math a little bit more tricky than the other problems that students were doing. Okay, let's start the math. So this is how I'm going to set up the function. Pi times the integration from 1.26 to 0 of 2x plus 1.5. It's a little messy. Squared dx minus pi times the integration from 1.26 to 0 again of 0.5 squared dx. Now this is the first part of what we need to do. And so this function, this first function, the equation that I set up top here, is this line right here. But it's that line up until that point, 1.26, where the 2x plus 1.5 intersects the negative 0.6 squared plus 5. And now to integrate this function, so we're integrating this area right here. And so it's that top function off of this function, y equals 0.5, which cuts across. It's a little bit high up, but you can see what I was getting at. Okay. So now I think you know what I'm trying to do with this pi and the squared and the dx, and that's really what that is I'm finding the rotational, the volume of the rotated figure. And in order to do that, we're rotating around the x-axis so that the figure, which is made up of infinite many dx's, is made into cylinders, stacked cylinders. And that's another part of the project that we worked on. We made a stacked disc representation of our clay pot. And because those are discs, we find the area, and the area, or the total of all the areas of each one of the discs, is pi r squared. Pi r squared is the area of the disc, and then all those discs added up, all that area added up, will be the volume of the figure, of the solid clay piece. And so this is important because that's the disc method, and this is what we're getting at in this calculus-based ceramics project. So the next step after simplifying this function that we have with the integrations, we're going to get the integration, or pi times the integration of, oh man, okay, we'll deal with that. Also scared of that. Pi times the integration of 4x squared plus 6x plus 2.25. And dx minus pi times 0.25, or the integration